Okay. Anyways, if you are watching this, if you are watching the recording, yeah, we are starting the session now, and this is the overview of the Sem 1 activities you can refer to. Right. Okay. So a little bit about myself. So my name is Jiale. You can just call me Jiale. And my handles. So I have my Telegram handle and some of my gaming account handles is Flamboy. I know it's weird, but it just comes from the word flamboyant. Yeah, just a random word. And then my Discord handle is 4F5DA2, which is even more weird, but this one has some meaning. Yeah, which some of you may know, but yeah, it has some meaning. Okay. All right. Then my course is year 3 CS, and this is my HIO page if you want to look at the games I have made. My favorite gaming genre is indie games. For example, the games like Don't Starve, Baba Is You, Ori are all the legend games that I love. So the games I'm currently playing, the list is probably too long to fit in this box. So yeah, we will do a proper round of introduction in our first physical session in the future, which will happen, I promise. Trust. Okay, yes, very relatable for many people here. Okay, let's start. So just a reminder that it's a chill session. So you can turn on your audio whenever you want. Just don't make it too disruptive. Yeah. So basically we just pretend it's a physical session. If you need any help, just you can either type in the chat or just ask me directly. Yeah. Okay, so let's do a proper introduction of Godot. What is Godot? Okay, Godot is the name of the character in Ace Attorney. Yes, that's what Godot is. I was so surprised when I see the name. Yeah, when I was playing the game. But yeah, actually this name is a French name. So it comes from the French name Godeau or something, right? And then some people change it to Godot, Godot, where the T is silent in this play. And then the design team, they chose this name to have some symbolic meanings, whatever. Anyways, the name is Godot. It is a free and open source game engine where the developers of games code the game logic and adding the assets to produce a game for people to play, basically. Yeah. Okay. Yeah. As I mentioned, Godot is free and open source, so there are many memes. Okay. There are many memes about many shit posts about Godot being free compared to other platforms. Yeah, so I'll say Godot, on my take is that Godot is very good for beginners or hobbyists to make games as a hobby, right? Yeah, it's not as powerful as other games, other game engines, especially in the 3D aspects, but it's very good as a starter. Yeah. And it's very good, very optimized for 2D games, especially. Yeah. All right. So yeah, just a rehash of the timeline that we're gonna have. So this week is the basic stuff. So we will get our hands dirty with the Godot editor. We will do some simple scripting and to try to understand the node structure of Godot. What does that mean and how is it powerful? How is it useful in our game development? And then we will try to make our player move. Yeah, to handle the movement of the player as the user input the keys. Yeah, so the end product is going to look something like this. Yeah, that's it. Very simple for the first workshop. So the workshop is going to be interactive. What do I mean by that is, I will not be like a lecturer to go through the concepts, right? So for most of the parts, I'll just do a live demo. So you guys can just follow me on your laptop and try to obtain the same results as I did. And then I'll also give you some hands-on activities for you to try and internalize the concepts so that you can do it on your own in the future. Yeah, so let's start. Oh, shit. Okay, so let's introduce ourselves to the Godot editor. So the first step is always to create a new project. All right, fun fact that Godot editor is a Godot game itself. That's amazing, right? So, where's my Godot? Wait. Let me open a new. Sorry about that. Okay, my Godot is here. Right, so I believe most of all of you have downloaded Godot as of now. So this is what you see after you download Godot, right? Normally, for a game engine or for any IDE, you will think this is an installer, right? So you would expect after you click on this, it's going to install an entire folder of libraries, scripts or something, right? But for Godot, it's not. This is the engine itself. So basically, this is a game made by the Godot developers using their script, their native script, and they pack it into a game and ship it to you. So when you develop using Godot, you're actually playing their game, right? We are playing the game of making a game. How cool is that? Right. Okay. So yeah, you guys can just open the executable file, right? And then just create a new project. Okay, maybe you can browse it to some location. Where should I put this projects? Workshops. Okay, let's create a new folder and name it whatever you want. Let's say my first Godot game. Okay, my first Godot game. All right, just choose forward plus and git, and we create and edit. Okay. Oh, if you have any questions, or if you think I'm too fast or too slow, you can just react in the Zoom so that, or you can. I think it's better if you just turn on your audio and tell me, yeah, because I may not see your reactions. So someone else. Okay, we have more people. All right, so for the people who just came, we are starting the workshop now. So we are just using the downloaded Godot script, Godot executable. So you can go there and create a new project. Yeah, just click on the new and then choose a location and create a new project. Yeah, we're just starting. So yeah. Okay, maybe. Oh, oh no, where is it? Hey, I saw someone in the waiting room just now. Okay, never mind. All right, so maybe now I'll explain what you see after you create a project. Projects. So you got too many projects. Okay. All right. So you will see these files being created when you start a project. So this .godot is basically the settings, the editor settings of this project, and also some cache so that it's faster when you open and develop the game next time. And these are just some Git files for you to use for version control, which we'll explain in the future, right? This icon.svg is the default asset they provide to you, which is a Godot icon. Oh, it opens the SVG actually. Okay, never mind. And this is the import file of the SVG. So basically, every asset you import into your project will have this import file that describes the attributes, the metadata of these assets. when you import it. And this is the main file that I want all of you to pay attention to. So this file is basically the Godot project file that, okay, so this is the entry point to your project. And next time when you want to open the project again, you can either choose it in the what do you call that, launcher just now, or you can open the Godot project and then you just drag this into your game editor. Then basically it opens this file. Or in the editor, you can open a new project and choose the file. Yeah, basically that's the entry point. Yeah. Okay, so now we are in the editor. Okay, so let me explain the different components of the editor. So on the top, you see these tabs. Yeah, these are just basic editor tabs that you find in any editors. So yeah, I think they are self-explanatory. Yeah, so you can just look at them later. Maybe important things to notice is these project settings, which you can configure some settings specific to your project, right? And also some editor settings that you can set for your editor, like the style, the text size, etc. Yeah. Okay. Okay. This tab is the scene tab. It's basically the current scene. So let's say we create a root node. We just choose a 2D scene. Right. I understand it's a bit difficult for you to refer to my video and your own editor. So maybe I'll go a bit slower. Okay. So you see that after creating a 2D scene, there is a node 2D object in your current scene tab. You can save it. Okay, you see this is currently unsaved, so you can press Ctrl S, or you can just go to scene and save scene. It's the same. Then just click save. Right. So what we did is that we have created a new scene, right? And then it appears as a file in our file system, right? So you can see the scene appear here as a node, right? So what's a scene and what's a node, right? Basically, a scene is a package of nodes, right? And a node is what can I say? It's just a different objects in your game. So let's say this node represents the scene itself, and you can add some child nodes to this node. Okay, the node we are going to add is the sprite 2D. So we can add a node and choose sprite 2D. Right, so you can see this object, sprite 2D, is being added to this node. Right. Sprite is basically the appearance of the object of this node, right? So maybe if you want, you can rename the objects. You can rename this object to, I don't know, appearance. Okay. Yeah, you can also press F2, which is a shortcut. Then what do we do with the appearance? Yeah, we can drag our asset into this texture, right? You see, or I mean, you can load the file from this tab as well. But usually we just drag this icon into the texture, and then we can see that this object now has an appearance, which is a Godot icon. Right. So this is back to this section. So this section is what we work with the objects in the current scene. Right. Remember that this is the scene, and these are the objects or the nodes in the current scene. Okay. Remember to press save. Maybe before we proceed, we can rename the scene, rename the object to game, and then we can rename the scene into game as well. Right. So now we have a game scene and a game object that we can use in the future. Okay. Yeah. And this file system is, I think it's quite clear that it contains all the files in your folder. If I create a new folder, then it's going to appear here, right? Okay. And you can also import assets into your game by just dragging your assets into this tab, into this file system. Let's say I go to, okay, you have the assets that I sent, right? So let's drag the night.png into this file system, right? You can see that it's being imported as a new file, as a new asset in your file system. All right. Okay, so these are these two tabs. All right. Okay, these tabs basically you toggle from the you toggle the current, what do you call this, coordinate system, the current workspace, be either 2D, 3D, or you can be editing the script. Yeah. And these are for you to do some editing or transformation in your current coordinate system. Yeah, so this stands for select. So after you click on this I believe, yeah, is move. You can move the object in the coordinates. You can rotate. Right. This is scale. Right. We'll explain them later. Just to get you familiar with the layout. Right. These are some other cool functionalities that is very useful when you develop a game. So you can check them later. For example, this one is to lock the node so that you cannot select them. Right. You can unlock them here. Yeah. These are just some convenient buttons that you can use to edit the current workspace. Okay, and on the right, we have the inspector. So basically the inspector will inspect all the properties of the current selected object. Right, so here we have a list of the properties of this appearance sprite. Okay, someone's Godot have crashed. Yeah. Okay, this one is when you click on this run button, right? Yeah, so we haven't covered that step yet. So don't run your project yet. You can just restart the project, and we'll cover that part later. Yeah. Okay, back to where we were. So we were talking about the inspectors, and you can see that these are the properties of this object. Let's say we can try to flip H. Flip H doesn't work since this is symmetric. Flip V, then it's flipped vertically. Right. So in the transform, we can change the position. So when you see that we drag the objects around, these properties get changed, right? So you can either change the properties here. You can also change them in this inspector, right? It's going to be changed correspondingly. Or later we'll also cover how to change them in the scripts. Right. The position, the scale, also the visibility. Yeah, all kinds of properties. And so this inspector allows you to look at the properties, or you can just change them temporarily in the inspector. Yeah, but usually we wouldn't change them here. We would just change them in the script or in this editor. Yeah. So these are more for displaying the properties. Okay. Yeah. So that's about it. And this, okay. On the bottom, there are a few tabs. So this output basically outputs the events that's happening in your project. So when you change this, it's going to tell you that what you have changed. And later, yeah, in the script, you can also output stuff to debug for debugging purposes. Okay, this debugger is some advanced tool for you to debug in your script later. This one are not so important. So this audio and animation is when you add the corresponding objects like the audio and animation objects in your game. And then you can configure some properties here. So this we'll cover this in 2 weeks later. Yeah, but they are not important for now. For now, you can just look at the output tab. Right. Okay, for the starting the project, right? They are here. These are the buttons you use to run the game, basically, right? So I believe you click on this one, right? When you run project, then it says no main scene has been defined. Okay, so the difference between these two buttons is that this button runs the game itself, the entire game itself. But this button will only run the current scene, right? So in order for you to run the entire project, you need to have a main scene so that the project knows which scene to initialize when it starts, right? If we want to look at the current scene, we should click on this. Okay, sorry, first time is a bit slow. Right, so we can see this is our current game. This is the current scene. Yeah, it's just a preview of the current scene. And how do we know which part of the coordinate system are we displaying? So basically it's this, you see this blue rectangle, right? This is called the viewport, right? Which means what the user sees when they start the game or when they view the scene, right? This blue rectangle will be displayed here. Okay, so this viewport settings is configurable in the project. Right, maybe you can toggle them to be a bit larger so that the default will be larger, right? If you change the viewport settings, and also you can change them to be full screen, etc. Yeah. So after we develop one scene, we usually just use this button to preview the current scene, right? But to preview a game, we will need to set a main scene, right? If you see this, you can select the current scene or you can select it from the file system, right? For today, we'll just select the game scene as the current scene, right? So in your file system, you can see that the main scene is marked as blue, right? If we have other scenes later, they will be white, but the main scene will be blue. And now you are able to view the entire project. Right? We are clicking this to view the entire project, and the project knows that the main scene is the game scene, so that it initializes the game with the main scene, which is the game scene. All right. Okay, up to this point, any questions? Everyone can follow? Okay, right. So let me go back to my slides. Okay, so these slides, I just put the concepts here in case you need to refer to them later, but I will not refer to the slides when I go through the live demo. Okay, so in the editor, as I mentioned, you can do all those transformations, right? So the buttons, remember the buttons that you can click to transform this object, right? So basically, there are a few shortcuts that you can use. So if you press Q, it toggles to the select mode, right? W is the move, E is rotate, and S is scale. Okay, it's also listed here as a shortcuts. Okay, Q, W, E, and S, right? So okay, now I'm at the select mode. Now if I press W, then it's a move, right? If I press E, I can rotate. So the rotation will be along this axis. Okay, if you see this little red cross here, that's the axis of rotation. I believe there's a button here, right? Rotation pivot. You can use this to move the pivot of rotation. And then you can go back to the rotation mode. So it's going to rotate along this pivot. Right. Okay, let's put it back. And then after I press S, it's going to be the scale mode. Okay, so just like your normal, I don't know, Windows Paint, some other editors that you can press Shift, you can long hold Shift, and then do your transformations. Right. So this will, yeah, this will, how do you call it? Okay, basically it will, okay, it's going to move in a straight line, right? It's going to scale as a with the aspect ratio being locked, etc. Yeah, it's just some simple shortcuts that you can use to edit your objects. So let's say we want to align this object to the top left. We'll either select it or we can press W to move it, right? We can align to the top left, and then we can scale it. Oh, okay, we can scale it a bit larger. We can align it again, right? And then we can preview the scene again so that it's being transformed, and yeah, you can preview it in the scene. Yeah, that's a basic transformations that Godot provides, right? So, okay, any questions? Okay, I think that's all for Godot editor. Okay, now we can move on to the fun stuff, which is writing the scripts. Okay, so how do we start writing a script? So basically, we attach a script to an object, right? So if you right-click an object or a node, right, there is an option to attach a script, right? Then, okay, so you can see this option template. So for now, we just don't choose a template. We just use an empty script, right? And yeah, so this it will fill in the path for you. So the path will be the same name as the node you select, right? So this creates a new script that's called game.gd. Okay, so GD stands for GD script, right? Godot script, which is very similar to Python, right? That means you can write stuff like 1 + 1. Yes, like okay. So var a equals 1 + 1. Okay, then you can print a. But unlike Python, you'll need this var. Oh, wait. Okay. Oh, okay. So never mind. Sorry. Okay. Let's first talk about the default functions that Godot provides, right? So the way to define a function in Godot is to use the func keyword, func, and then you put the function name, right? And then anything, right? Yeah, which is quite similar to Python, but the keyword is func, right? This pass just does nothing. Okay, so one default function that Godot provides is ready, _ready. Okay, so this function will be called when this object is created and added to the game, right? For now, you can think about it like this, which means this will just be called once when your game is run for our situation. Okay, so let's say we can define something here, var a equals 1 + 1, then print a. Right. Okay. So Let's run the game. You can see that 2 is being printed here. Right, so basically, okay, when the game starts, this game object is being added to the game. And then this function is called. So it executes these scripts and then prints 2 into the output. Right, okay, now we can test the stuff we know about Python. Okay, what do we know? Okay, so okay, let's just first talk about the var and constant, right? Which is not Python, but Godot syntax. So constant means something that you can't change in the future, right? But variable means you can change the value in the future. So for constant, we usually use them for some physical constants or some attributes that never change for your character or for your game. Let's say we have constant, what? Constant speed equals 100, equals 1,000, right? So basically it declares a constant that is not going to change in the future. But you can also declare a variable. Okay, what variable can we have? Let's say it's a direction equals 1. So in the game, the player may change direction, right? So if we define the right direction to be 1 and the left direction to be -1, then this variable is going to change, right? So it makes more sense to declare it as a variable instead of a constant, which will change in the script later. Oh. Never mind. Okay, so for newcomers, we went through the process of navigating around the editor. Yeah. So now we are writing the script. Okay, so if you want to follow, just create a new Godot project, right? And then attach. Then you can create some nodes here, and then attach a script. Then you can start writing the script. Okay, but anyways, let's proceed with writing the script. So in this function, we can access the constant and variables that we declared outside this function, right? So we can print speed and print direction, right? Okay, I'm not going to run it. So basically, it's going to print 1,000 and print 1 and print 2. Yeah. But let's say we want to change the speed. Okay, we say speed equals 2,000, right? It's going to throw an error because this is a constant that is not supposed to be changed. But instead, we can change the direction. Okay, direction equals -1. So we are allowed to change the variable. Right? Now, when we print, it's going to output the modified variable. Okay. Yeah, that's the difference between constant variables. Okay. And all right. Okay, another thing is if statements, right? So for those who are new to programming, basically this is a conditional statement that executes the branch after the statement if only the statement is true, right? So if only the statement is true, let's say we can say if direction equals 1, print moving to the right. Okay, what this means is that if the value of the current variable direction is equal to 1, then this is going to be executed. Otherwise, this line will be skipped. Okay, then there are some corresponding keywords. So this elif means else if, which declares another branch. So if this is fulfilled, right, this will be ignored. But if this is not, it's going to execute this line. to evaluate another condition. So elif direction equals -1, print moving to the left. Yeah. I hope this is intuitive for those who are new to programming. So if it's 1, we print this. If it's not 1, but -1, we print this. Okay, that's another keyword called else, which means none of the above is fulfilled. We'll go to this last default branch, else branch. Print not moving. Okay, yeah. So that's a if else statements, conditional statements that we can use. Okay, so if we run this, because the current direction is set to be -1, then it will print moving to the left. Okay, right. Okay, so we can also define new functions in our script. Let's define it below the ready function. So let's say this is something we want to reuse a lot. We don't want to repeat these few lines many times in the ready function. So we can define a function. Let's call it print direction, right? Which takes in an argument, let's say direction. Then, okay, let's just call it direction. Then we move the logic inside this function. Right, so basically we define a function that we can call repeatedly in other places. So in the ready function, we can say print direction. Okay, or we don't even need this parameter or argument because this direction is being declared at the global scope, right? We can just remove this. So this direction will still refer to this variable. Then it's going to work the same. Okay, then, okay, let me just print direction. And then after that, I just change the variable to be 0, which means the player not moving, right? Then I print direction. Okay. By the way, this is mainly for those who are new to programming. Okay, if you are familiar with Python, at the meantime, you can just do all kinds of experiments you know about Python in this editor, and then just try any random stuff you want to try. Yeah. Okay, so let's see. Okay, so let's go through the process. So the direction is being set to -1, and then this function is being called. So when this function is called, it checks the current value of direction. Because it's -1, it will print moving to the left. Right. After this function is done, it's complete, it goes back to continue in this ready function. Then the direction is being changed to 0 and you print again. So it's going to print not moving. Right. Okay, right. So this is how you declare and use a function in your script. Okay, what else? Right, you can also use the logic statements. Right. So let's say we want to declare a variable to know if the player is moving to the right and moving very fast. Okay, we want to check both of these conditions, right? We can declare a variable moving to right and fast equals to a condition that we can use our logic operators, which okay, let's say direction equals 1 and speed larger than 500. Right. So this AND operator basically these two conditions, or you can say these two Boolean values, Boolean statements. Okay, so this basically the logic. So if both are true, then the entire statement will be true. Then this variable will be true. Okay. Then print moving to the right. Yeah, false. Okay. Okay, since the direction is 0, it will be false. Yeah. You can also use other operators like or, and you can use the, oh no, you can use the brackets to bracket them together, or direction is -1. Right. So this means that this entire thing, oh shit, what is this direction? Why is it? Oh, okay. Yeah, okay, so this logic operator, basically, it means that it will evaluate this statement first. So first, it's going to check if the speed is larger than 500 or direction is -1. And then this entire thing will be used in this statement. So direction is 1 and the entire thing. Then it's going to assign to this value. All right, so I mean, you will learn all this in your programming course. I'm just introducing that the things you can do with Godot scripts in your game. Okay, I think I've gone through a bit too much in the syntax. Okay, so for the syntax, you guys can explore later in your projects. Okay, let's continue. So we have explained what the underscore ready does. Right, there is another function that is called underscore physics process delta. Okay, so this one is another default function provided by Godot. Right, what it means that it's going to be executed once every delta time passed. So the delta is just, how do I say? It's just the physics frame. The frame, it depends on your frame rate. Okay. So let's say your frame rate is 60 frames per second. Then this delta will be 1 second divided by 60. So it's the length, the duration of each frame. And this physics process will be called every frame. Right. So let's say we print a new frame. Okay. Then we run the run. So you can see the string a new frame is printed for every frame, right? You can also print the delta to see what's the delta value that we can use. I mean, this delta value, you need it because sometimes you need to calculate stuff based on this delta, but you need to calculate how much the player moves per frame, right? You need to use the velocity times this delta to get the value. So that's why we need the delta. Okay, you can also implement some counter, count equals 0. So per frame, you can increment the count by 1. So count this means count equals count plus 1. And then you print current count is print count. Right. So it's going to print the count per frame. It's going to count one more per frame and it's going to print it. Right. Okay, you can see that the count increases. Okay. Right. So these two functions are very useful when we develop our game. You can probably feel it now. Right. So we can check stuff, check the properties of the player or check the input of the user in every frame. And then we make some changes to the character or something. Okay. Right. Any questions about the syntax? Everyone can follow? Okay, cool. There's another thing, which is you can access the documentation with control key. Right. So let's say you forget what this physics process function does. You can just long hold the control key and then left click. So it's going to direct you to the corresponding documentation that you can read about the function. Okay, right. Yeah. Yeah, that's it. So, okay, that's all about scripting. Okay, so now we will talk about the node structure, right? We created a node just now, but that's only one simple node, right? So what the node structure is like. So basically, both of these are nodes, right? These are objects and these are nodes. And then this node can have its own children. And its children can have its own children as well. So each of these is, you can imagine it as a branch or a tree if you're familiar with programming. Yeah. So basically, each node is a branch that contains the child nodes, which themselves are branches as well. Right? It's similar to your file system. If you think about your file system, and this is a larger folder that contains another folder, right? This folder also has folders and some files. Yeah, the folder can have other folders. Yeah, that's basically the node structure, right? So how can we utilize this node structure? Okay, we need to create another scene to illustrate. So let's just we can click here to create a new scene as well. Okay, let's create a new scene. We choose 2D scene, right? And we want this scene to be our player scene, right? And after that, we will add the player into our game to illustrate the node structure. Right? So before we start to add the child, right? Let me talk about the type of themes. We can save the theme first. We can call it player first and save it first. Right? Just the same process of creating the game scene. Right. So each node has a type, right? If you hover over the node, it says the type is node 2D, which is the most basic type, most basic 2D type of any node, right? But we can define the node to be some other types so that they can have some default properties, right? So the game engine, it provides some default types that we can use. Let's say, most games have a character, right? So we can change the type of the node to be character body 2D, right? So this is just another type of node that has some default properties that a normal node 2D doesn't have. Okay, we can change the type into character body 2D. Okay, yeah. So normally, when you start creating a scene, you should know what type it is. You should change it as soon as possible, so that if you change later, there may be problems that certain types are not compatible with each other, right? So try to change as soon as possible. So after we have changed, then the icon has been changed to this I don't know, small monkey icon. Then there is a warning says that this node has no shape, right? Why is there a warning here? Because this type is different from the node 2D, right? Node 2D, there is no restriction at all. But this type, there are some default stuff that you must provide for it to work, right? So this node says that it needs to have a shape so that it can collide and interact with other objects. So the shape is referring to the collision shape, right? So if we just search, sorry. So if we just add a child node, right, and then we search collision, we can see there are two: collision polygon 2D and collision shape 2D. So now we will choose the collision shape 2D, right? this is a child node of the player object, of the player node, right? So now this is a shape, and we need to tell the editor what shape it is, right? So we can go to the inspector and then choose among the types we have. So for now, okay, let's just choose a new circle shape 2D first. After you have chosen a shape, it's going to appear in the editor, this blue background, which represents the collision shape of the player. Maybe okay, it looks out of nowhere. Okay, maybe it's clearer if we add the sprite first. Okay, we will add a child item, which is the sprite 2D. And remember the same process, we will drag the asset into the texture of the sprite 2D. Okay, we drag the night image into the texture. Right, now our player object has this child object, which is the sprite, which stands for its appearance, right? And then it also has a collision shape 2D, which means the collision shape of the player, right? Now we can, it's more intuitive that we should change the collision shape to match the player icon or the player image, right? So yeah, we can use the transformations that we described just now, right? So I can press S and then long hold shift to adjust the collision shape. Okay, you may wonder why the sprite is above the collision shape, right? So if we move the sprite above the collision shape, they are going to reorder. Basically, the further down an object is in the same level, the more front it is, right? So now we can arrange it so that the collision shape is at the front. Okay, if we are not happy with the shape, we can change to other shapes. Okay, let's say we can choose a rectangle shape. We can choose a capsule shape, right? Anything that suits your need for this object, right? Okay, now we have added a collision shape to the player. Right? Actually, for this player, right, I will demonstrate another collision shape. I'll remove this first. We can add a collision polygon 2D, right? So instead of the predefined shapes, you can actually choose your own shape, because you see our character is not a capsule or it's not a circle, right? So it makes more sense if you give it a polygon collision shape. So how we do is you see this orange square, right? Oh yeah. Oh, I think okay, you need to press Q to be in the select mode first, and then you just select any position inside the orange square so that it creates a point, and then it's basically connecting the dots. Yeah. Okay, let's connect. You just outline the player, right? Okay, anyhow, okay, at last you can connect to the first point. You can see now the collision shape is the perfect polygon that outlines the player, right? Which is the best for our game, probably. Okay, right. So this is a collision polygon. And usually for a game, right, there are enemies and there are enemy bullets, right? So we want to have something that detects those bullets. That thing is in a node, it should be called area 2D. Right? It's basically an area that can detect the entry of other objects, which we'll cover in the next workshop. Let's just do it first. So we can create an area 2D that is called the hitbox. Okay, and then this hitbox also requires a shape. The area needs to have a shape, right? So the same, we just add a collision shape to the. Okay, just the same process. Maybe this time we want it to be simpler. We'll just add a capsule. Right, a bit down. Okay, yeah. All right, so now we have a hitbox for the player. The shape is this collision shape 2D. Right. So now if we look at the player object, you can see the hierarchy, right? So it has, on the player level, there are 3 children, sprite 2D, the appearance, the collision shape, and the hitbox, which is an area. Then under the area, there is a child, which is collision shape 2D, which is a direct child of this object, but not the player object, right? So this is the node structure for this player scene that we have defined. Okay. Right, you can see there's a layer structure that the player can have an object or a node that has other nodes. Right. So basically that's what node structure means. Okay, right. And then if we have completed this scene, right, we can go back to our game scene. Right. We want to add the player into our game. How do we do that? We can right click on the game node, right? There's an option to instantiate child scene, right? Then we can choose a scene that we have, which is a player scene. So this is going to create a player object and add it to the game node. All right. Okay, so the player object is this entire thing, is this entire tree or node structure, right? Then in the game, you have a player. So the entire, hey, how come I click and then we never, okay, never mind. Okay, I think he got in. Okay, so okay, for the newcomers, sorry that we are halfway into the tutorial already, but you can just open a Godot object and try to follow what we do. Then later you can check the recording. Yeah. So we are talking about the node structure. Okay. So in the game node, we have created a player node, right? And then the player is this entire thing. So you can imagine that the whole game has a player, right? The player is a child of the game. And then in the player, it has all these nodes as the child of the player, right? And of course, the hitbox also has a child node, right? So this is an entire system of different levels of the game that we have defined. Okay, right. Okay. So in this game scene, the player itself is an entire object, right? You can move the player, you can make changes to the player itself, right? Then all the child of this player will change accordingly and reflect in the game. Right. So if we start the game now, it's going to look like that, and the collision shape, etc., is going to be scaled and positioned at the same base position of this player object. All right. Okay, that's intuitive, right? Yeah. And creating objects, changing the attributes together as a group. Yeah. Okay, any questions up to this point? Okay, if not, I'm going to challenge you. Okay, so now is our first hands-on activity to apply what you have learned. So your goal is to add a new scene that is the platform. right? So use the sprite I gave you, use the asset I gave you, the platform asset. And the platform should have this type. Okay, static body 2D. Let me just show you the type. So okay, let's say I show you creating a new scene, changing the type to static body 2D. Right. So basically, this what it means, as what it looks like, is a body that doesn't move. Right. It's I mean it's suitable for our goal, which is a static platform, right? So we just choose this static body 2D. Yeah. Okay. And then our goal is to create this with the sprite and this collision shape, and then try to create some of these platforms in the game node. Clear? Okay. Maybe until 8:45, 8:46. All right. Okay. You can try to do this on your own. All right. Any question can just ask me, or can ask our other Expo members in the chat. All right, it's 8:46. How's everyone doing? Can react. If you're down, just react with something. Right. Okay, so yeah, we should see something like this. So in the platform scene, there's a sprite and there's a collision polygon outlined to be the shape of the platform, right? And in our game scene, we can instantiate all these platforms, right? We can also just Control C and click on the game and Control V. Then this will create a copy, which these will be different objects, but they have the same properties, right? Okay, let's leave this. All right. So yeah, this is our game now. Okay, I remove the Godot sprite. This is our game now. Okay. So if we play the game, it's like that. Everything is static because we haven't added any script to the player. Okay, so next step, we will be scripting the player so that we can make the player move. All right. Okay, so the same process of adding a script to a node. We right click on the node and attach a script. And this time we will select the template option to use the existing script file. Right. So basically, I think this is a new feature in Godot 4 or one of the recent versions that they provide the template script for us. So it's easier for us to develop the default behavior of an object, right? So once we have added the template script, we can run the game. Let's see what the default script does. Right. So you can see that the player has fallen onto the platform. Right? You can move left, and right. If you click up, it doesn't work. But you can click space for it to jump. Yeah, like that. Okay. And play around with it. Okay, anyone not able to see this? Please tell me. Okay, we're all set. So let's look at the code, right? Let's try to understand what the code does. Okay, so the code defines a constant speed and a constant jump velocity, right? Then it gets this gravity variable from the settings. Right, so this is the default gravity. I should open. I'm just trying to open room chat in case. Okay, so this is a default gravity setting in our project settings, right? We can change it in the project settings. And yeah, I can see the location of physics to the default gravity, right? Okay. These are just the default configuration, right? So we have a gravity value. And okay, if the character is not on floor, if not is on floor, then we will increase the y value of the velocity with the gravity. Right now, okay, I'm just trying to describe what the code will look like in general, right? So what this does is if the player is not on the floor, means it's in the air, right? Then it's going to increase its y value of velocity by the acceleration times time. So v equals at, right? So yeah, that means it increases the velocity based on the gravity. Yeah, this is to add the gravity. All the syntax I'll explain later, just to get get a overall grasp of what this does, right? So yeah, so it gets some input, right? And if this is the space button, if it's on floor and the space button is being pressed, then it's going to jump. In case you're wondering, why gravity is plus, right? So if we go to the plane, right? You can see from these markings that actually for the y direction, downward is positive, upward is negative, right? So if you add velocity, it means it has a downward velocity. The velocity is more downward. Okay. Similarly, if you want to make it move downward, you need to increase its position, the y value of the position. The value should increase for it to move downward, right? That's just a convention for the sign. Okay, so this is to handle the jump, right? And this is to handle the left and right movement. So it gets the input of left and right, and then changes the horizontal velocity based on the direction and the speed. And then it does. And this is the key thing that makes the player move, right? So it moves and slides. Basically, it translates the velocity value into the actual movement, right? So which I'll explain later. Yeah, so you can see that our goal is something like this, okay? We're going to set some default values and handle the gravity, the jump, and the horizontal movements, right? Okay, but before this, let's remove the physics process. Okay, let's remove this. We will try to get the essence of the movement. So what I mean by the essence of movement is the properties of this character object that controls its movement. So there are two properties. One is position, one is velocity, right? You can see from the inspector, I think. Not the inspector. Transform. Okay, maybe I'm not sure if you can change the velocity here, but there's a position, right? So the current position is 0, 0, right? And let's say we code it so that in each frame, the position increased by 1. Each of these values increased by 1, right? Then, okay, let's make it simple first. So in each frame, the x position increased by 1, so that it moves to the right gradually, right? How will we do that? So there is a property of the player, of the character body, that is position. You can just refer to it by this position variable, right? It means the position property of this player. Then this property, if you hover, I cannot hover. Okay, this value is the type is vector 2D. Basically, it's a 2D vector with two values, right? So okay, let's first print this position first. Okay, let's print position. Print position, and see what the position looks like. So we print position. You may wonder why this is not 0, 0. That means it's actually printing from the game, not the player scene, printing from the game scene where the global position is not 0, 0, but this value. Okay, but anyways, the position is a vector. It's a 2D vector with two values. First value is the x position, and the second value is the y position. All right. Okay. Now, how do we access one of these values? Very simple. Just position.x. Position.x. Right. This refers to the x value of this position. In this case, it's 117. Position.x. And print position.y. Right. Okay, let's start again. Then it's x and y, right? So these are the values. So how do we set the position? Let me do this. We can set one value at a time, or we can set the entire vector at the time. Okay. We can either just position dot x plus equals 1. Okay. This means I set the x value of the position to increase by 1. Or position plus equals vector 2d, vector 2, bracket 1, 0. Okay, so what this means, this is basically a vector, a 2D vector that we have created. And we add that vector with this position vector. We all learned about vector addition, right? So we just add these vectors so that the x value will increase by 1, right? It's the same as position dot x plus equals 1. Okay, let's try. You can see that the players is gradually moving to the right. Okay, yeah. Okay, so let's say we want to account for the speed of the player, right? So let's say we want the player to move to the right at this speed, right? Instead of this. How do we do that? So basically, we will need to add the, okay, let's use that one as simpler. Position dot x plus equals delta times v. Okay, position is time times velocity, if I'm not wrong, right? So yeah, the delta, as I mentioned, is just the duration of each frame. So in each frame, you increase the x position by the frame duration times the speed, right? Right, it's like that. Okay, so it's moving at the speed that we defined here. All right, this is how we naively move an object by changing its position property, right? We can also set the velocity property. Let's say we remove this, and that's a velocity property. Let's say we define it to be a constant vector 2 of 1, 0. Okay. Now the velocity is there, but it's not being applied. So how we apply is just to call the move and slide function. Sorry, wait. Okay. I think this. Okay, it doesn't work like that. Sorry. So if we want to define it naively, right, we still need to write something like position equals speed. Position plus equals velocity, which is a vector times delta. Yeah, we can also do something like this, where we define the velocity property of the player, that is a vector 2D. And then we change the position by velocity times the delta. Yeah, it's the same thing. Okay, so this is we ultimately needs to change the position, but this is a bit, how do I call it? This is not ideal, since there are many things that we need to care about, like the collision and stuff, right? So what Godot does for us is to provide this move and slide function. Okay, so if we look at, so it will move the body based on velocity, right? But the condition that it should collide with some other bodies, and then it will slide along the other body. Right. Okay. So how do we do that? We first need to make those. Sorry, it's a player.gd. We need to make the player collide with the platform first, and then make it move and slide. So remember the gravity, right? So we need to change the velocity to be increase it by the gravity times delta. Right? And then let's say we set the velocity, no, velocity dot y, which is changing the y value to increase by the gravitational acceleration times the delta. And then let's say we set the velocity dot x equals 1. Okay, now we let it move and slide. Okay, you see that it is actually moving, but very slow. Okay, so what it happens is that okay, let me set it a bit higher and then right. So what happens is that in each frame, it has a velocity that is downward and rightward, and then it will move and slide. So basically, Godot helps us handle the collision with other objects. It's going to move along the colliding objects until it's at the wall that it cannot move anymore. So basically, move and slide will just move the object in a common sense. So it's an intuitive movement. It will slide along a ramp if the ramp is not too deep. The ramp is not too steep, right? Then if the ramp is too steep, it cannot slide over the ramp, and then it just stops there, which I believe is a parameter that you can set somewhere, so that it's able to pass some ramps. It's going to slide through some ramps that you can set. Okay, anyways, for now we just need to remember that for the movement, we will handle the velocity, and at the end we just move and slide, right? So let the engine handle the movement for us. Okay, so now we are ready to read some user inputs and then use that to change the velocity, right? So how did the script get the user input? Is using this property input dot get is action just pressed, or is action pressed. Right, what this means, just if the user is pressing the input or not. Okay, we will write UI accept here and something. Okay, so what does UI accept mean? Yeah. So to look at the actions, the user inputs, we need to go to project settings. Right, and there is a tab called input map. Right, basically it contains all the names and the actual keys that the user press, right? The name for the keys that the user press. So we should toggle this on, show built-in actions, right? These are the default actions that the engine provides, right? You can see that UI accept, this is the name of these keys. So it maps this UI accept name to these keys, right? Basically, when the user presses space, and this user event called UI accept will be triggered. And then your script will be able to detect that this UI accept event, this action is being pressed. All right. Yeah, okay. So for this one, we want to add something. Let's say we want to make the player jump, right? So velocity dot y minus equals, oh no, plus equals. Since the velocity is already negative, which means upward, so here we plus the jump velocity. Oh, sorry, it should be an if statement. So if the input, if we detect this input, we don't need the bracket, then we change the vertical velocity to be this, right? Let's see. Oh no. Okay, what happened just now is that when we keep holding this UI accept, then the velocity keeps increasing. But okay, so sorry, it should be equals jump velocity. So we set the velocity to be jump velocity instead of plus equals. Oh, okay, right? Yeah, now it's like this. So you can see that it can jump infinitely, right? We don't want that. We only want the player to be able to jump when it's on the floor, right? So Godot has this very convenient function. It's just called its own floor. If it's on floor and we press this button, then we are going to jump. Right. So now we cannot jump infinitely. Right. What this is on floor does is that it reads from the last move and slide. Okay, if we go to this, it actually looks at the last call of move and slide. It is able to detect the collisions of this player, right? Then because when in the last call of move and slide, the player is colliding with the platform beneath the player, right? Then it detects a normal force from the platform upwards, right? And then it's going to tell that the player is on the floor. Yeah, very, very, very smart. So you can just call its own floor, and then, yeah, if both are fulfilled, then you set the velocity. There are also other functions you can use, like its own ceiling, its own wall, which has the same logic. It just checks the previous collision and checks the normal force. So if the normal force follows certain direction, then it knows that the player is at these states. Okay. All right. It is on floor. Okay, now we have handled the vertical movement. So now we will look at the horizontal movement. And okay, I think I need to show another thing, which is adding the input maps. So let's say we want the player to be able to jump both by pressing the space key or by the up key, right? So what we do is we will need an or input dot is action pressed UI up. This is just another user action that is the up key, right? Okay, if you feel the line is too long, that's just like in Python, you can use this backslash and then break into two lines. So now both space and up will work. And let's say you are one of the players that prefer to use WASD, and it is not there by default, right? So what we do here is go to our input map, we find the UI up, right? Then we can add some keys to this event or to this action. So we just press this add new key, add new event, and it says listening for input, right? You just input a key. So let's say you input W, right? So this means that it will bind this UI up event, UI up action with this W key. now you can see that the W key is added to this event. Okay, similarly, you can feel free to add A to UI left and D to UI right. Right. Okay, so now when we press W, the event is also going to be picked up. Okay. Okay, any questions up to this point? Okay, cool. Now let's go to the horizontal movements. But before that, I need you guys to help me scan our event QR code. Okay, let me just okay. Can you guys help me scan this code and just join the event? It's our annual async event for NUSGDG sessions. Yeah, to prove that we are still active, we have members. Yay. Okay, please help, please help. 30 seconds, help me. You just have to scan and yeah, log into your account. Then it should be marked as attending the event. All right, thanks for helping me. And now let's go back. So for the left and right, it's similar. So let's just try to apply the naive way. So if the right is pressed, we move right. If left is pressed, we move left. Right? If input dot is action pressed, UI left. Then velocity dot x. And I can remove this one. Left is minus equals speed. Then elif input dot is action press. Okay, simple logic. It should not be, it should be equals minus equals. I was thinking about position, but not velocity. We should set the velocity to be the speed, and then we let move and slide handle the movement. Okay, following, right? If we have this, then with the user inputs that we have just now, we should be able to press WASD to move. Okay, you can see there is some bug. Okay, now it doesn't stop, right? Now it doesn't stop. Yeah, it's intended because we never decrease the velocity. Right. So how do we decrease the velocity then? Okay, of course you can else. So if neither left or right is pressed, you set velocity dot x is 0. Right, that will work, right? But here let's demonstrate friction, right? So else, if nothing is being pressed, right, we will gradually change the velocity from the current 1 to 0, right? So in the previous template script, they use this velocity dot x equals, there's a function called move toward from the initial velocity to 0 by some constant, right? What this means is just a linear movement from the current velocity to 0 by 10. So this two is just to determine the direction of the movement. And then this is the value of the movement. Very simple, right? So this just decrease the velocity by 10. Or it increases if it is negative. Right? So if we look at this, right, you can see that the velocity gradually drops, and it doesn't look very natural, right? Since it's decreasing linearly. Right? Okay, that's one way to make the player stop. Right here, I'll introduce for me is a more natural way. So this function is called loop f. Right, it takes the same number of arguments, but the third argument should be smaller. Okay. So what loop f does is also moving from the initial value to the target value, but this is the proportion that it moves. So it's like a linear interpolation. It moves towards this by this proportion in each frame, right? So you can imagine that it decreases by a lot initially, and then the decreased amount is gradually decreasing. Right, can look at this, right? So each frame is going to decrease the velocity, the absolute value of the velocity by 10%. Right. Like that. Okay, yeah. All right. This is the use of loop f. Okay, everyone clear about loop f? Okay, let's see. Is our player able to jump to the last? Okay, if the player is not able to jump to the last platform, we need to increase these constants. Let's say minus 600, which means the velocity is more upwards when the player jumps. So the player jumps is able to jump higher now. Okay. Okay. Right. All right. That's pretty much it, actually. There is also one thing I want to show you, which is the horizontal flip of the character when we move left and right. So if we go to Sprite 2D, there is a property called flip H and flip V, which I showed just now, right? So what we want to do is we want to change these values. Okay, so we want to toggle the flip H based on whether the player is moving left or moving right. Right? How should we do that? Right, we should determine it from the current velocity of the player, right? So if the current x velocity is negative, we know that the player is moving left. Then we can set the flip H value. We should have an if statement. Velocity of x is smaller than 0. Then our next step is to try to access this flip H value. Okay, this is a bit advanced into next week's topic, but let's drag this sprite 2D object into our code. You can see here is a $sign sprite 2D, which is trying to access the child of the current object by the name sprite 2D. Then we can access the properties of this object. Let's say flip H equals false, which means we don't flip the horizontal. And else if velocity of x is larger than 0. Oh, sorry, less than 0, it means it's moving leftwards, so it should be true. Right. Then when it's moving to the right, we shouldn't flip the H. False. right? So this is an example of setting the property based on the property, yeah, in the game. And yeah, we're able to change the direction of the sprite in the game through our script. Okay, right. Is everyone able to follow up to this point? If yes, please give me a thumbs up. Okay, if you face any issue, please don't feel shy to just open the audio and shout. Yeah. All right. Okay, I think it's 9:22 already. Actually, I have another hands-on activity for you. Let's see if we still have time. Okay, I think for these ones you can try, maybe you can try later if you're interested. So basically our current movement is still not ideal, right? There are a few problems. So this is one problem because we can see that the friction in the air is the same as the friction on the ground uh, because this is the step we use to handle the friction, right? So if you look at it, if I make it more clear, like 0.05, which means the friction is less. Yeah, you can in the air and on the ground, it's the same friction, which is not real, doesn't feel real, right? So my hands-on activity for you, which is is to make the friction smaller in the air. So the player is able to to I don't know to travel freely in the air more than on the ground. On the ground, it should stop immediately, nearly immediately when you don't press. But in the air, it can travel a bit more. Yeah, this is quite simple. I think it will be quite simple if you change the code logic. Yeah, you can just change add some conditional statements here, right? Based on whether the player is on the floor or not. Yeah, just try it in your free time. And there are also some other issues. Let's say when both left and right keys are being pressed, or if you are pressing the right key and then you just press the left key, what should the behavior be? Normally, we want the player to be able to change direction, even he's pressing the other direction, right? So if it's pressing right and then I press left, it should move left. But currently, it works in one direction, but not the other direction. You see, if I press left and then right, then it doesn't change direction. Yeah, like that. So this is a bit annoying. And yeah, so maybe the homework or any additional practice for you to try is try to solve this issue on your own, right? Try to explore how to change the logic so that you're able to handle this case. Okay, yeah, that's the end of today's workshop. So today we covered all the basic stuff with Godot. How do you play around with the editor and add some basic logic to your code. And next week we are going to look at some more advanced basic stuff, which are the physics and the logic in your scripts. So we'll look at how to handle the collision, right? So how do we determine if the player should collide with some objects but not with some other projects, right? How do we know that they are colliding? And how do we access the objects that's being collided? And the signals. So signals is basically, it's basically an event that happens when some other event that's triggered by some other events. Right? So let's say an event is the bullet entering the player's body. Then we should send a signal to signal our objects and our code that this event is happening and we should do something about it. Yeah. So that's about the signals. And also accessing how do we access the other nodes and how do we group them so that we can edit them in batch. Yeah. Which allows you to code more complicated games. Okay. Right. Any questions? Any last questions? Okay, if not, we will end here and just do the additional practice if you want. You can try to use your own assets and make any game you want. Yeah, with the skill you learned. Yeah. So, okay, so we'll end off here and see you in next week's workshop. Yeah, the same time, hopefully physically, but most likely you'll see online. Okay, see you. Bye bye.
Thank you.
Thank you.